guys that this was the stuff that really made me excited about math. And, well, no. Definitely this is different. So I'm going to help you guys out here. So this is an assignment. We'll do one together, and then you guys will do the rest. You'll have the rest of the hour to work. We're going to do one together, then you have to do 6 for homework. So this is your first homework assignment from section 2.4. Now, I read you guys what is referred to as the formal definition of the limit. Now, what we need to do is we're going to introduce this idea of the formal. Again, formal means that before we had an informal. And we encountered the problem that on Friday we looked at, like, remember the barcode function and stuff like that? And the idea was, how close is close enough to get to X to say, well, yeah, that's where the limit is. Because, again, some of you guys came up with slopes of 1.1. Some of you came up with 1.01. Some of you came up with 1. They're all technically estimations. Okay, how close do we have to get to ensure that it is, in fact, say exactly 1? So here's what we're going to do. We're going to look to try to ensure, but I got to add something here. It says, for the following functions, A, sketch a general graph, including the limit and the tolerance. I'll show you what that is. B, identify the X value needed to ensure the limit is within the given tolerance. And C, make a statement about choosing appropriate X values to ensure the tolerance. So I got done writing up the answer key, and then I looked back and said, gosh darn. I said, all it is functions and numbers, and we should definitely have somewhere in there where we're describing what happens. So we're going to make a statement. So I really think that everybody's going to understand this. This is good. This is going to be good for your brain. You're like, oh yeah, I like that. I like what's happening. Okay. So we have this limit right here. So the idea is we want to try to work towards a formal definition of the limit. And it says the limit is x approaches 2 of x squared minus 1. Can you tell me what does the graph of x squared minus 1 look like? It's a parabola. Down 1. Very good. So let's just sketch that. Now, if I plug in, can I substitute the value 2 to see what the limit is? Yeah. In fact, if we use substitution, we can identify that the limit is probably, we can't ensure that it is, but it's probably going to be what? 3. And the reason why I say probably is this. It's a nice behaving function. It doesn't do anything real crazy. It doesn't have gaps. So I'm going to sketch this graph, and it looks like something like that. Yeah? All right. Now I want you guys to know something. My drawing is not going to be to scale. Because if we want to arrive within a tolerance of 0.1 or a tolerance of 0.01 of the limit, there's no way that my sketching can be that close. So it's okay if from this point out it's not going to be accurate, okay? So here's the idea. This is my limit. My limit is equal to what? 3. Okay? What I want to do, you guys are going to move towards actually proving that the limit is 3. But what if I was going to be within a tolerance of 0.1? I wanted to be within 0.1 of that limit. What would be my upper bound? 3.1. And again, this is not going to be to scale, I understand. The question is, what x value would correspond to that 3.1? Well, Larry, how would you find out? What would you do? How would you set it up? Very good. Let's set up all of our equations. What would my lower bound be? 2.9. And again, I know that this is not to scale. You can see how convoluted it all gets up here. Give me an equation to represent that. Okay, now let's do the next part. The next part says tolerance within 0.01. What would be my upper bound for that? Yep, 3.01. What's my equation? I'm going to do it in the first example, then I'll tell you what you need to do moving forward. But please ask the question again if I don't answer. X squared minus 1 is equal to 3.01. And what's my lower bound for that tolerance? The value in drawing it is that you understand that you're getting around the limit. You also understand that these are pretty close together down here, aren't they? And so understanding that is important. If you can draw these and understand that this top is 3.1, this bottom is 2.9, in the middle I have 2.99 and 3.01, that those can correspond to those values, then that's fine. You don't have to write everything in there. But you do have to understand that that's exactly where it comes from. I would like you to at least do this. You don't necessarily have to sketch them all. Sketch at least 2 of them. So the upper and lower for one of them. Okay? Just so I understand once you do it once, you're probably like, okay, I know what's happening now, but we just got it. We got to put the visual together of what's happening. So x squared minus 1 equals 2.99. Okay, so it's time to solve here. So x squared minus 1 equals 3.1. Does somebody have a calculator? So you can follow along. Looks like I already solved these out. I've got x squared is equal to 4.1. I square root both sides, and I get x is equal to 2.02. Right. So how do I know I have the positive value? Because of my graph, exactly. So Megan's correct. I would have the negative 2.02 as well. That would be the other side of the graph. But because I know I'm approaching a positive 2, I can really just focus on that portion of it. But that's something to really keep in mind. That does happen throughout the worksheet in a couple of spots. So I've got 2.02, and I'm going to, let's see, that's this value right here. 2.02. It's not exactly 2.02, is it? Okay, so you can estimate to the nearest 100th or 1000th if you would like, but for sure at least the 100th for these. Then I have x squared is equal to 3.9. I square root both sides and I get approximately 1.97. And that's going to be this spot right here, 1.97. So let me ask you this question. If we want to ensure that our tolerance of error for the limit is going to be within 0.1, how close do I have to be to my x value? How close do I have to get, approximately? 0.02 or 0.03. So if you look at how far each of these are from the value 2, 0.02 or 0.03, that's how far you are from that value. So if you look right here, this is 1.97, this is 2.02, you're within 0.02 or 0.03 of your x value. So that's that value that you have to get to. Okay? Now remember when I was reading off the definition, the formal definition, I'll read it off one more time, and then so this should help connect a little bit. It says, you don't just try to pick up some words that you aren't familiar with yet, okay? Then the limit as x approaches a of the function is equal to L. We're okay there, right? If for every number epsilon greater than 0, there is a number delta greater than 0. Epsilon delta, kind of weird, right? Epsilon is going to be your tolerance of error for the top. So every time you pick a tolerance on top, there's an x value on the bottom, a distance from that x value. So our delta in this situation is going to be that 0.02 or that 0.03. So given a tolerance of 0.01, for the top, we have a tolerance for the bottom, say 0.02 or 0.03. Let's look at the next one, and you'll understand. Nothing confusing how we got these numbers, right? Okay, so I just want you to practice doing that process, making the drawing, and after a few of those skill building pieces, I think tomorrow we should be in good shape to tackle the little bit bigger piece. So now I solve here. X squared is equal to 4.01, and x squared is equal to 3.99. And when you square root those, it's about 2.002 and 1.997. So now I'm going to make my statement. To ensure a tolerance within, and we're going to choose a smaller one. We're just going to make one statement using a smaller one. So to ensure a tolerance within 0.01 of the limit, choose an x value within, how small do we have to get? Yeah, we got to choose a smaller one. Which one's smaller, 0.002 or 0.003? Yeah, so within 0.002 of x equals 2. That's what you're approaching. So what we've said is we just want to know how close do we have to get. And right now, the question is 0.1 small enough? Is 0.01 small enough? None of it's small enough. In mathematics, we have to get infinitely small. So we're going to practice getting pretty small, and then tomorrow we're going to get, actually Wednesday, we're going to get infinitely small. And then your brain will explode. So, and you will do it. That's what I want you to do for each one. You have the rest of the hour to work. 6 problems. Please work only on this. Please, 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 please. I have the answer key, except for the very last problem. I got 2 things to try real quick. Yes, sir. Why? Skipper. All right. Okay. turn on.